Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. So, you've got the basics down. Log laws like product, quotient, power, and change of base. But can you actually use them to simplify messy expressions or evaluate tricky logs without a calculator? In this video, we'll tackle intermediate log problems that combine multiple rules, require strategic thinking, and push your understanding to the next level. Let's jump in. So for the first problem, we're going to expand a log expression. So when we say expand, we mean we want to write this as multiple logs instead of just one. So to expand this, we're going to use our product and quotient rule. So we can see that within the log function, we have a division happening, which means we can split this into two logs. The first one being log base 2 of 8x cubed, and then we minus log base 2 of y times the square root of z. And now within each log, we have multiplication going on, which means we can split them further into log base 2 of 8 plus log base 2 of x cubed minus log base 2 of y. Let's put a bracket around there. And then we have plus log base 2 of square root z. And log base 2 of 8, we can actually just evaluate that, and it becomes 3. And then for the next term, we're going to pull our power to the front. So that's 3 times log base 2 of x. And then we have minus log base 2 of y. Distributing that minus sign will give us minus log base 2 of square root z as well. But we can actually go one step further since square root of z is just z to the power of 1/2. So that means we can pull the 1/2 to the front and it becomes minus 1/2 times log base 2 of z. For the next problem, we want to do the opposite. So we want to simplify this expression, which means we want to actually combine all these multiple logs into just one log expression. So we're going to put this 2 back up as an exponent. So this is going to be log base 5 of x squared plus log base 5 of y minus log base 5 of z to the power of 1/2. And now we can use our product and quotient rule to combine these three terms into one, which means we would have log base 5 of x squared times y divided by z to the power of 1/2. And then if you want, you can actually write this as log base 5 of x squared times y over the square root of z. Okay, so moving on to the next problem. Again, this one's a simplify, which means we want to write it in terms of one log and numbers. So we get this is equal to log, and notice how we don't have a base here, so that means it's naturally a base 10. So this would be log base 10 of 10 plus log x squared plus log of x to the power of negative 1/2. So now log 10, that is just equal to 1. And then we can combine the next two terms into one log. So that would be log of x squared times x to the power of negative 1/2. And now we can combine x squared times x to the power of negative 1/2. So this becomes 1 plus log of x to the power of 3 over 2. And then finally, we can pull that 3 over 2 to the front. So our expression is going to be 1 plus 3 over 2 times log x. So for this question, we're not asked to simplify or expand, but we're given that log 5 is equal to a, log 3 is equal to b, and log 2 is equal to c. And we want to express this expression here in terms of a, b, and c. So that kind of tells us that we want to rewrite this in terms of log 5, log 3, and log 2. So then the first thing we notice is that 45 is equal to 5 times 9, and 9 is just 3 squared. So we're going to go ahead and rewrite this as log base 2 of 45 is equal to log base 2 of 5 times 3 squared. So now we can go ahead and use our product rule and rewrite this as log base 2 of 5 plus log base 2 of 3 squared. And then we can now use our power rule to pull that 2 to the front. So that would be 2 times log base 2 of 3. And notice how right now we still have log base 2, but we're given log 5, log 3, log 2, all of which are in base 10. So that gives us a hint that we should be performing a change of base here. So we're going to actually rewrite log base 2 of 5 as log 5 over log 2. And our 2 times log base 2 of 3 is going to be 2 times log 3 divided by log 2. And now everything is in terms of log 5, log 2, and log 3. So that means we can go ahead and rewrite this in terms of A, B, and C. So we end up with A plus 2B over C. So now our last question, we're asked to evaluate this expression here without a calculator. So even though we've been mostly using our log rules and they're very powerful, we still can't forget the definition of log. So for this question, we're going to let 27 to the power of log base 81 of 7 equal to x. And x is the answer that we're trying to find. But notice how this here is just an exponential equation. We have our base, which is 27. We have our exponent, which is log base 81 of 7, and it's equal to x. So that tells us we can actually rewrite this as log base 27 of x is equal to log base 81 of 7. So notice how 27 and 81 are both powers of 3. So let's go ahead and actually do a change of base here so that we can rewrite both of them in terms of log base 3. So that means the left side becomes log base 3 of x over log base 3 of 27. And then the right-hand side becomes log base 3 of 7 over log base 3 of 81. And now we get log base 3 of x over 3 is equal to log base 3 of 7 over 4. But really, log base 3 of x over 3 is the same as 1/3 times log base 3 of x. So we want to do that because now we can actually move that 1/3 up as an exponent. And we get log base 3 of x to the power of 1/3 is equal to log base 3 of 7 to the power of 1/4. And since both sides are now log base 3, we can just compare the input. So that means we can just compare what's inside the function, which is x to the power of 1 over 3 on the left-hand side and 7 to the power of 1 over 4 on the right-hand side. So that means we set them equal to each other and then find our x. So we end up with x is equal to 7 to the power of 3 over 4. And now let's do a quick recap of what we have gone over in this video. So we went over how to use log laws to expand or condense complex expressions. We went over examples where we had to combine product, quotient, and power rules and apply them strategically. We learned that the change of base rule can help us rewrite logs in different bases, especially when you're given known log values. And then finally, Even though we have been working with all these different types of log rules, the definition of a log is still very useful and can help us evaluate solutions. So now it is your turn to give this a try. Given A is equal to log 3 and B is equal to log 7, can you find the exact values of those three expressions below? Make sure to leave your answer in the comments below and let us know if you'd like to see more content on logs in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.